So in the last section we just did, we were graphing hyperbolas from an equation. So in this section, can we do the same thing we've been doing for the other conic sections? Given some information about the conic section, can we write the equation that would give us that hyperbola? And for hyperbolas, the only things we can really be given will be the vertices and the foci, because those are the only two key parts that we have that determine a unique hyperbola. In our first example then, we're given vertices at 3, 0 and negative 3, 0, and foci at 5, 0 and negative 5, 0. I think that it's helpful to draw a quick sketch of the information that we have. So we have vertices at 3 and negative 3. We have foci at 5 and negative 5. And our hyperbolas are going to be opening up through those vertices around those foci. So we see that it's opening up to the sides. So this is going to be x squared minus y squared. The first thing that we maybe want to figure out is where is the center. So what's right in the middle of 3, 0 and negative 3, 0? 0, 0. So our center is at 0, 0. So it's not shifted anywhere. So we know that our equation is going to have x squared over something minus y squared over something equals 1. Okay? It's not shifted anywhere, so it's just x squared and it's just y squared. And then we need to fill in what our x radius is and our y radius. So the x radius should be the easier part, because from our center to the vertices is our x radius. So from the center to the vertices is a distance of 3. So down here we should see 3 squared, and 3 squared is 9. So the only other part we're missing is underneath the y squared. Remember, for hyperbolas, our foci, we find the distance to the foci by doing c squared equals a squared plus b squared, where c is the distance to the foci. So in this case, that's 5, right? Distance out to the foci is 5, so c is 5, so c squared is 25. And then, since these are added, it doesn't really matter which is which, but one of our two radiuses, one of those is 9, right? Our distance to our vertices was 3, so 3 squared is 9. So this first one would be 9. We can call this other one b squared. So subtract 9 from both sides, and b squared in this case is 16. We don't need to take the square root of that and get that the distance to the top that would help make our box. We don't need to know that that distance is 4, because when we put that back in the general equation, this would be 4 squared, which is the 16. So we can stop right there once we get b squared. We don't need to go one step further just to come back one step. So the equation for this hyperbola would be x squared over 9 minus y squared over 16 is equal to 1. This next example will probably seem a little more complicated because we're shifting where our center is. This one's not centered around 0, 0, so it'll take a little bit more thought. But still, I think the most helpful thing to do from the start is draw a sketch of what we have. So we've got hyperbola where we have vertices at 4, 1 and 4, negative 3. And we have foci at 4, 9, so pretty far up there, and 4, negative 11, so pretty far down there. But what this lets us see is our hyperbola is going to be opening up and down. So this is a y squared minus x squared. So we can kind of set up our general equation. So it's going to be y something squared over something minus x something squared over something equals 1. So let's find the center. The center is going to be halfway between our vertices at 4, 1 and 4, negative 3. Well, from 1 to negative 3, that's a distance of 4. So halfway between that would just be 2 units. So it looks like our center is at 4, negative 1. If you don't want to think through it that way and don't want to try counting, you can just do the midpoint formula from section 1 with the vertices, and that will give you the midpoint. So we're at 4, negative 1. So we want to shift right 4. So in our general equation, we should see x minus 4. And if we want to shift down 1, we should see y plus 1. Okay? So that will get us to our center. Then we also see that the distance from the center to our vertices, so up and down, is 2. So our y radius is 2. So underneath our y, we should see 2 squared, and 2 squared is 4. So we have 4 underneath there. So the last part is finding this b squared. So again, we know the distance to the foci squared, so c squared equals a squared plus b squared for a hyperbola. What's the distance to each of our foci? So from 4, negative 1 to get down to negative 11, that's a distance of 10. So in this case, c is 10. So c squared would be 10 squared. So that's 100 equals a squared. A squared is 4 plus b squared. Subtract 4 from both sides. And b squared is going to be 96. We don't need to go further and take the square root because we would just undo that. So b squared is 96. So that's what will go under x on the other side of that on that fraction. So it looks like the equation for this hyperbola would be y plus 1 squared over 4 minus x minus 4 squared over 96 is equal to 1.